afternoon. So, first of all, please don't forget that on Friday we have a midterm. Arrive on time and do bring your student ID. And please make sure that your ID looks like you, like your picture, so I can that you didn't wash it in the pocket of your jeans. I should be able to identify your face. Okay. So today I'll go over several types of problems that are most important to remember and to learn. So as number one, I put know your antiderivatives. This is obvious. These are in the table. You have to remember those. Now, Riemann sums, okay? And estimating definite integrals. So I'll give you the best way to approach a class of problems that is very common. So let's suppose that I have a table of values. Okay, for instance, 1, 2, 3, 4, 5, 6. For x at these discrete points. So if you have any questions, please ask me. If you don't, and you don't, please don't talk. Okay? Question?
Will the Riemann sums will be evaluating be in this kind of format right here?
Not necessarily, but this is one possible format.
Okay.
So the functions f can be given. For instance, I could have numbers here, or I could have f of x equals x minus 1. Okay. If I have this formula, I can fill in the values here. If I don't have a formula, perhaps I'm given the values. So let's use this example. So the values are minus 1, 0, 1, 2, 3.
You forgot 3.
4, 5. This is an example. So let's suppose that we want to approximate the integral between 0 and 6 f of x dx by using n equals 3 and the midpoint rule. Okay. So at this point, I suggest strongly you do the following. You draw the domain of x between 0 and 6 like this. Okay. So you have 0, 6. This is very easy to draw. Now you look at the problem itself. It gives you the following information: n equals 3 and midpoint rule. Okay, I'm going to draw this on this little diagram to make it perfectly clear what is required. So n equals 3 means that I have to split this domain into 3 parts. And that's very easy. Like this, right? And right away, I can write down delta x. What is delta x? 2. It's 6 over 3 is 2. And this is already very important. Now, so this follows from n equals 3. The second piece of information here is the midpoint rule. What do I have to do? I have to identify the point at which I need to evaluate f in my sum. Midpoint rule means that in each interval, I have to take the middle. This, this, and this. Okay? So these crosses tell me what values of f to use. So my integral f of x dx is going to be approximated by the following. F of 1 plus f of 3 plus f of 5 times delta x. Okay, and now I look at the table. What is it? 0 plus 2 plus 4 times 2 is 12. Okay, and I'm done. Okay, so 2 pieces of information. How many intervals I have and what rule I use. Let's change the problem. Let's now use not the midpoint rule, left hand rule. What do I do now? What changes? I still have n equals 3, so my 3 intervals survive. It's the same. But now I have to evaluate the function at the left side of each subinterval. So where do I evaluate it? Here, here, and here. Can you see that? So this corresponds to midpoint. So for left hand, I have f of 0 plus f of 2 plus f of 4 delta x. So what's the answer? Minus 1 plus 1 plus 3 is 6. Different answer. If it wasn't the left-hand rule, but right-hand rule, what would change? Again, the points would change. For the first interval, I would use this point. For the second interval, I would use this point. For the last interval, I would use this point. So I would have f of 2, f of 4, and f of 6. Let's change something else. Let's change n. Let's suppose that I have n equals 2. So not n equals 3, but n equals 2. I would have to start over. And split this interval into not 3, but 2 intervals, like this. In this case, delta x is 3, right? Okay? And so on. So these are the steps that you take, always, for such problems. Questions? Question?
Will we be required to draw the picture?
Can't remember. Can't hear you.
Will we be required to draw the picture for the midterm, or are you just testing it?
You're not required, but if you don't draw it, you're more likely to make a mistake. Question?
Will we be able to use either Riemann sum or definite integral, or will you specifically ask for one of each?
These are specific questions. Question?
Do we need to bring like a specific type of testing paper, or is it just?
No. I'll give you the midterm on print it. Bring pencil and paper. Oh, I'm sorry. Bring pencil and eraser. Don't bring paper. And in fact, you're not allowed to have any extra paper. I give you extra paper. There was one more question there. It's okay. Fine. Now, next topic. So this was 2. 3 is fundamental theorem of calculus. Parts 1 and 2. So for part 1, what is a typical question? So given the function g of x from sine x to 6 of tangent squared t dt, find dg dx. Okay, this is a typical problem. And the first thing that you must remember is that you never differentiate the integrand here. Okay, And then you have to see where x appears in the definition of g. Is it at the top limit? Is it at the bottom limit? Is it at both? Okay. So in this particular case, we only have it at the bottom. So dg dx is minus. Then I have to differentiate this d dx of sine x times tangent squared of what? Of this guy, sine x. So I have minus cosine x tangent squared of sine x. If my limit, if this one was constant and I had sine x here, I would not have the minus sign, right? If I had both functions of x, I would have two terms. One coming from the differentiation of the top limit minus the term coming from the differentiation of the bottom limit. Questions? They want me to do another problem like this. Yes? Let's suppose g of x is given by 5x squared cosine x squared of x plus t plus 1 dt. Okay? So what's dg dx? I'm going to have two terms. The top term comes from the differentiating the top limit, d dx of cos x times this function evaluated at cos x minus, because this is the bottom limit, d dx 5x squared times the integrand evaluated at 5x squared. So the only step that I have to perform after this is the actual differentiation. Okay, so I have minus sine x cos x plus 1 minus 10x 5x squared plus 1. I can stop here. Okay, no more simplification. Okay, so this is part 1 of the fundamental theory of calculus. Part 2 is remembering what happens when we perform definite integration. So part 2. So an integral from a to b f of x dx is f of b minus f of a. Everybody knows this. But how about this? A to b f prime of x dx. What's that equal to? I have to take the antiderivative of f prime. What's the antiderivative of f prime? F. So f of b minus f of a. So if I'm given the function f at points b and a, I can evaluate this integral exactly, just by using these 2 points. Okay? So you should remember both incarnations of this theorem. Fine. Now, next, substitution rule. So that's 4. Substitution. Out of many techniques of integration, we only know one. Okay, that's substitution rule. So if I have square root of 5x squared plus 6 times x dx. How do I evaluate this integral? I notice that if I take this function and differentiate it, I get something like x times a constant. So I use a substitution. U equals 5x squared plus 6. So du is 10x dx, or x dx is du over 10. So I have 1 over 10 du square root of u. Okay, so I was able to rewrite this in terms of u only, or I can say u minus 1/2. And now it's very easy to take the integral. So I have u 1/2 divided by 1/2 plus c. The last step, I remember what was my definition of u. So I have 5x squared plus 6 divided by 5 plus c, and that's the answer. Okay. How about this? An integral log squared x from 2 to 4 dx. Okay, so this is a definite integral. That's the only difference. So I notice that I have log x, and I notice that I have a derivative of log x here. What's the derivative of log? 1 over x. So a good choice of u would be to set it to be log x, which gives me that du is 1 over x dx. So here I have u squared du. Right? I rewrote it. I'm forgetting one thing here, which is the limits. The limits, I didn't have to worry about those for the indefinite integral. Now I have to worry about the limits. What happens to the limits? So x goes from 2 to 4. So when x equals 2, what happens to u? U is log 2, right? When x equals 4, u is log 4. So my limits change. And that's what I should never forget. Okay? When I have a definite integral, not only do I transform the integrand, I also transform the limits of integration. And now the rest is easy. I have log 4 cubed minus log 2 cubed over 3. Do I have to add c? No, it's a definite integral. It's a number. And if I have an answer like this, I don't have to simplify it.
If you change the u's back to the x values, you don't have to change the limits, correct?
Right. This is a better way, though. Next is the net change theorem. Questions? So that was 5. The net change theorem. Suppose that population grows at rate c equals 2t year minus 1. Okay, so time is measured in years. The rate of change is measured in years minus 1. Find the increment in the population size between t equals 1 year and t equals 2 years. Okay? So this is a standard problem that tests your knowledge of the net change theorem. And of course, the theorem states that to get the net change, you have to integrate the rate of change. So we integrate from 1 to 2 c dt. So I have 2t dt. So I have t squared from 1 to 2, 4 minus 1, 3. Okay, the population changes by 3 per year. I don't know, 3, maybe 3,000. Depends on what you measured in. Stick with the units that are given in the problem. Okay. Okay. Now, let's address applications of integration. These are kind of perhaps the most recent problems, so they tend to be more confusing. So area between curves. So suppose, so let's say calculate the area enclosed between curves y equals x and y equals x to the 5 and x greater than 0. Okay? So this is the condition. Let's draw these two curves. One of them is a straight line, and the other one is kind of like this. So the standard way to proceed is find, even if I don't know how to draw them, right? The next step is standard. I find points of intersection. Find the points of intersection. What do? I equate the two curves. X equals x to the 5. Or I can say x to the 5 minus x equals 0. Or I can say x to the 4th minus 1 equals 0. What are the solutions? There are 3 solutions here. X equals 0, right? X equals 1, and x equals minus 1. And this is what I see on my graph, right? They intersect at 0, of course. This point is 1, and this point is minus 1. So if I didn't have this condition, I would have to calculate the area between the two curves in these two regions, right? How would I proceed? I could say the picture is symmetric. So let's calculate this one and multiply by 2. Question?
Was there a condition x has to be greater than 0, though?
So in the problem that I formulated for you right now, I included this in the problem.
Okay.
If it's not there, then you have to calculate the area of both.
Okay.
This condition actually tells you that you don't need the left one. Okay? It makes it easier, actually. So the area is given by the integral between 0 and 1 of y top minus y bottom dx. Okay? And here I can see that y top is a straight line, so it's x minus x to the 5. Okay. So I have x squared over 2 minus x 6 over 6. And this is the answer. Questions? Question?
So if you had to calculate, if it didn't have x greater than 0, if it was from -1 to 1, could you just use symmetry and just find 0 to 1 and then multiply by 2?
So that's a good question. Suppose we did not have the condition x greater than 0. Okay? So just for now, let's suppose that this is the new problem. Then the area would still be like this. Okay? So this formula is always correct. Oh, no. Sorry. Then I would have to integrate from -1 to 1, right? Y top minus y bottom. This is correct. Except these two switch midway, right? So one way to do this is to split the interval into the interval between -1 and 0. And then I have x to the 5 minus x dx plus an integral from 0 to 1, x minus x to the 5 dx. You see, they have a different sign. On the left, x to the 5 is on top. On the right, x is on top. Or I could be clever and I could say, okay, if I need the area between the two, this is a symmetric picture. Let's calculate this area just once and multiply by 2. It's up to you. In this case, we have the symmetry, nice symmetry property. Okay? But so the answer is going to be twice this, 2/3. You can do it like this systematically, or you can say, I calculate it once and I multiply by 2. Questions? Question?
Do we have to memorize like special graphs, like log x, e to the x?
You should, from 2a, you should know the behavior of these functions, whether they grow, decay. Like you should know that e to the x, for instance, never crosses 0, and it grows. So this is e to the x, and this is e to the minus x. You should know that the log is only defined for positive, stuff like that. You are expected to know these things for the entire duration of 2b. So you may have problems that require this knowledge. So now let me calculate some volumes. Okay, so let's call this region R. Okay, and we're going to play with solids of rotation. So this is number 7, volumes. So consider region R defined in the previous problem. Okay, rotated around the axis y equals -1. Calculate the volume. So this is my region R, right? The axis of rotation is y equals -1. So because it's a solid of revolution, the cross sections that I'm going to make in this direction, the direction perpendicular to the axis of rotation, the cross sections look like donuts or washers. And they have radii y out and y in. What we need to do is to calculate the two radii. How do we do this? There's always the same algorithm. Let's so this is 0, this is 1. Right? Let's suppose we have cross section at level x. Okay. So the outer radius, what is it defined by? It's the distance between the center of this solid. Where is the center? It's at the axis of rotation. So the axis is given by y equals -1. So from here all the way to the outer surface, which is given by this curve, right? So y out equals to x minus -1. -1 is this point. This is x, because this is my outer curve. If this was sine x or cosine x, that's what I would put here, right? So this is the outer function, which is further away. You can see it from the picture. That's why it really helps to draw a picture when you do these things. You know which one is further away. And the distance between that outer function and the axis of rotation is given by this. So I can simplify it to x plus 1. Now y in, the inner radius, is the distance between the axis of rotation and the function that's closer. In this case, it's x to the 5, right? So it's x to the 5 minus -1. So these are the two radii. And now I can calculate the area of the intersection. So if it's a washer like this, you take the area of the outer circle minus the area of the hole. So it's pi y out squared minus pi y in squared. This is always the formula for washers. And I use my values for y out and y in that I just found. So I have x plus 1 squared minus x 5 plus 1 squared. So at this point, we have to simplify. Before we insert this formula into the integral, this is the time to simplify it as much as we can. Okay? Which usually means expand the squares. So what do I have here? X squared plus 2x plus 1 minus x to 10, right? Minus 2x to the 5 minus 1. Usually something will cancel. In this case, 1's cancel. And that's it. So I have x squared plus 2x.
Isn't it positive 2x to the 5th?
2x?
2x to the 5th.
No, because this comes from this and there's a minus in front. So this is my formula that I will be substituting into the integral. Questions so far?
Can you explain how you calculated the y out and in? Do you always subtract like the
Yes, so
values? Is it always subtracted by the value given?
So let's suppose I have f and I have g, okay? And they make some region in my space. And my axis of rotation is given by y axis. Okay, some value. In that case, it's -1. How do I so I rotate around this. How do you calculate the inner and the outer radii of the washers? So imagine this thing. This is the axis of rotation. I take this and I rotate it like this. Okay, so this is the motion it makes. And I set up an arbitrary point x. Okay, so for this x, what's the outer radius? It's the distance between the middle, which is the axis of rotation, and the function that's further away from the axis of rotation. So y out, in this case, is f of x minus y-axis, minus this point. In my example, this was -1, -1. Okay, so it's the distance between this point and this point. That's my y outer. Let me see if I have a different color. So this is y out. Okay, corresponding to this value of x. What's y in? That's this distance between here and here. So this is y in, and it's equal to y in is g of x, this function, minus y axis. Okay. Question?
Is it always going to be the function minus whatever the axis is?
It's the distance between the function and the axis.
Okay.
So it's always going to be something like this. We will next consider a problem where I rotate around a vertical axis, in which case I'll be measuring it in this direction.
Okay, so even if the functions were, let's say we're rotating it about y equals -1 and the functions are down in the fourth quadrant, is it still going to be?
Oh, so if the functions are here,
Yes.
so if the functions are, for instance, like this, so this is, you probably can't even see it. So the outer radius is the distance between the axis of rotation and the function that's further away. So that's going to be the more negative one. Okay? And the y in would be the distance between the axis of rotation and this one.
Okay.
And how do you measure distance? You take the difference. And you can take the absolute value of the distance, of the difference, right? That's the distance. You would have to measure the distance between the axis of rotation and the two functions. Mm-hmm. Okay, so now let's go back. So I did it for this particular example. I calculated y out, and that gave me the area of the outer circle minus the area of the hole. I simplified it. And the last step is to insert this into the formula for volume. Okay. So continuing with my example, the volume is given by an integral between 0 and 1, a of x dx. So I have pi, and I put in whatever simplification I obtained. And from now on, all I need to do is integrate. Let's see. So I have pi. Yes, so I have 1/3 plus 1 minus 1/3 minus 1 over 11. So this is the answer, the numerical answer. So this is not so bad. You can do this completely without using calculator, right? So this is approximately the level of, arithmetics that you have to perform. This is not so bad. Now let me take the same shape and rotate it around a vertical axis, right? So next, take region R and rotate it with respect to axis x equals 2. Okay, so picture. Region R looks like this. This is 1. So x equals 2 is this axis. So now the motion happens in this direction. And I still have washers if I dissect them in this direction, which means I have to integrate in terms of y, not in terms of x. So the volume can be given as an integral of a of y dy. So what are the limits of integration? X goes from 0 to 1, and my functions are, so this is x, y equals x, and this is y equals x to the fifth. So this point is actually also 1 in terms of y. So y also goes from 0 to 1 in this example. So what I need to do is figure out the cross sections, the areas of cross sections, right? So let's do that. So the trick here is that x's and y's switch over. So my donut looks like this, with outer radius x out and the inner radius x in. Okay? And let me draw it on this picture. How do I calculate x, the radii? So let's set a current coordinate y. Y is going to be changing from 0 to 1. I'll have to explore all of these cross sections. For a current y, how do I determine the outer radius? So this is the center. This is the axis. The outer radius is the distance between the axis and the function that's further away. Okay? So this distance, let me mark it like this. So this is x out. The inner radius is this. Okay, this is the inner radius is the distance between the axis of rotation and the function that's closer to it. Okay, so let's write it down. And I have to express x in terms of y as opposed to y in terms of x. So my original functions are y equals x and y equals x to the 5, expressed in y. So I have to say x, I have to resolve this simple equation for x, so that's trivial, x equals y. And this one, I have to say what is x in terms of y. I have to solve it for x. X equals y 1/5. Okay, so this is different. I have to rewrite my functions by changing, x and y. So now I know what is what. So x out is this function expressed in terms of y, right? So it's y minus the axis of rotation is 2. That's it. X in is y to 1/5 minus 2. Questions? Question?
You know how the limits are 0 and 1?
Mm-hmm.
If it started out as y, would we have to solve it?
You have to figure out the new limits. In this particular problem, the new limits are also 0 to 1. So, but they don't have to be. So whatever this function is, so the limit in x is 1. You have to find what this point is.
Try to solve for x.
So
But would it be the same way to find the intersection, like make the y?
you already found the intersections. So you know that the x coordinate of intersection, you know it. Now you have to find the y coordinate of the intersection. And that's easy because you know x. If you know x, you know y from either of these equations. Okay? So this is a good question. You always have to worry about the limits of integration when you go to y. They may be different. You have to find out what the y coordinates of the points of intersection are. Okay? So now, if I know the two radii, I know that a of y is pi x out squared minus x in squared. So I have to do this. Y minus 2 squared minus y to the 5th minus 2. Okay. What do I do now? Simplify. Always at this stage, expand the squares and try to simplify it as much as possible. Oop, 4. And look, usually, as I said, something cancels. Okay. So this is my function. Now, the volume is an integral from 0 to 1, a of y dy, pi, and I put that guy in here. From now on, conceptually, again, it's very easy. Y cubed over 3 from 0 to 1. Last step. Did I get it all wrong? To 5th. 7/5. Yes, it's all good. So allow me to write down the answer. It won't be that bad. Okay. So this is a little bit more heavy in terms of algebra. So here the answer is given by this. Okay. So I just want to hear your questions with regards to this. And so the last topic that I didn't mention is, I believe it's 8, right? The average value of a function. So f average is when you have to evaluate the average value on an interval from a to b, you have to integrate from a to b and divide by the length of the interval. Thank you.